Hello, our team name is the Citronauts, aka Group 2, and today we're going to be briefly going over our final project. My name is Daniel Case, and I'll be talking about the servo experiment that I had the opportunity to create. The overall goal of this project was to successfully code and build Arduino devices that could measure either distances or temperature and calibrate them accordingly as well and log data for some cases. Our plan was to gather on a weekly basis to discuss our responsibilities and how we were going to perform each experiment in a precise way to get our pre-desired outcome. We each divided up one of the 4 projects to each group member to perform and gather their own data from their individual Arduino project to code and construct, as well as later utilize for statistical analysis. Some steps and stages were followed to construct the system where hooking each one of the 3 wires to the correct corresponding ports on the Arduino, making sure the Arduino had power and that the code had no errors and was working properly. Some of the problems we faced were debugging the fractured code, which took some time and patience to figure out, as well as correctly constructing the project with all the given materials and hooking them up to the Arduino correctly. We overcame them by referencing the Laughing starter kit as well as the online resources. The calibration of the servo motor consisted of correctly adjusting parameters in the code to adjust speed, as well as properly inserting the wires into the correct ground and power pins on the Arduino board. Some principles that I've learned from this experiment is that gathering a large data set can give you a better insight when calibrating your project and perfecting your code to get the desired output. This can be translated to a future career in engineering when you need to record a large quantity a large quantity of current draw values for a motor running under colder temperature, causing it to be less efficient when you want to improve efficiency.
I am Sean Clay from Group 12, and I was responsible for the water level measurement system. To set up the Unoboard, we first started by procuring it and making sure that it was clean of any code before starting. We then connected the positive pin of the sensor to the 5-volt power source of the board and connected the negative pin of the sensor to the ground. We then connected the S pin of the sensor to the A0 storage space on the Unoboard. After that, we uploaded the code using the Arduino software and did some basic diagnostic checks. One of the problems we faced in the experiment were some bugs in the code, but those were easily fixed using the resources from the class as well as some online forums for Arduino. We did have to adjust the code to get it lined up correctly. From this, we learned important engineering concepts of how coding works and as well as how to set up hardware. A real-world example of the water level measurement would be on a submarine. You would need to know how far you are below the surface of the water at any time, and this is the sensor you would use for that.
Hello, my name is Daniel O'Donnell, and I will be going over the contactless distance measurements using the ultrasonic sensor. The steps to build this experiment and to have it function properly are as follows. First, connect the Arduino Uno board to a computer that has the Arduino IDE installed and download the provided code. Then connect the VCC pin of a sensor to the 5-volt power source on the Arduino, the trigger pin of a sensor to the D12 port on the board, the echo pin of a sensor to the D11 port of the board, and finally the ground pin of a sensor to the ground pin on the board. Now that the experiment is properly built, the code needs to be adjusted. Connect the Arduino to the computer and open the IDE. In the code, you will need to make 2 adjustments. The first is to add the new ping header file so that the board is able to communicate with the sensor. And the second is to change the definitions from the trigger pin to port 12 and the echo pin to port 11. Now verify and run the code, open the serial monitor at 115,200 baud, and you will see the data. The significance of this experiment is how the baud rate affects serial communication. Baud rate is related to the speed of data transmission in a system, and the higher the baud rate, the more data is transferred in bits per second. An example where this is applicable is in telecommunications and electronics. If a machine is outputting data in serial for our case, we need to know what the baud rate is so we can read what the machine is outputting. If we have the wrong baud rate, the data will be indecipherable or inaccurate.
Hello, I'm Brendan Donofrio, and today I'm going to be going over the Thermistor Arduino project. So, some of the problems I encountered during this project were placing the wrong resistance resistor in series with the thermistor, and getting the code to work correctly. Both of these issues caused great fluctuation in the temperature readings I was getting. Fixing these allowed me to gain the experience of knowing what my data set should look like and trying to correct my equipment to properly represent it. These skills are useful in the engineering field, as well as the skills acquired by learning basic knowledge about how to set up circuits. So I began by setting up the circuit as described in the instructions. We hooked up the thermistor and the resistor that operates at the same resistance as the thermistor. And then we connected one end of the thermistor to the power, which is plugged into the 5-volt on the Arduino board, and which is also connected to the power of the LCD sensor. At the junction point of the resistor and the thermistor, we connected that to the data slot A0. And then at the end of the resistor, it was connected to the ground, which is connected to the ground on the Arduino board.